welcome to CodeSoft. In this video, we are going to talk about the question subarray with given sum. So let's get started. Now, what does the problem statement says? It says we are given an unsorted array of non-negative integers and we need to find a continuous subarray that adds up to a given number. So let's say we are having an array that is 1, 4, 23, 10 and 5. So we need to find a subarray in this array that will sum up to 33. Okay, so in this case, you can see that if we start an array from 20 and go till 10, this will sum up to 33. 20 plus 3 plus 10 sums up to 33. So this is our required answer. So I hope the question is clear. I would request you to pause the video and try it on your own. If you're not able to, then please have a look at this problem. So the naive solution says that go to each element one by one, that is traverse the array once. At each element of the array, traverse the rest of the array to create subarrays and then compare it with the sum, that is the required sum. So if we ever in this case encounter that subarray sum is equal to the required sum, just return the indexes of both the traversing loop. Okay, clear. This solution takes the complexity of O of n square because we are traversing two loops. Now, what do I mean by the problem is that go to that first traverse the array, that is go to each element one by one. Suppose we go to 1 first, right? Then from that element traverse the remaining elements one by one. First, like from 1 traverse the remaining element. So first we go to 4, and while traversing the remaining array, just keep counting the sum. So from 1 we go to 4, we count the sum equal to 5. Compare it with 33. If not equal to 33, add the next element. We add 20. Still not equal to 33. Add next element. Still not. Add the next element. Whenever the sum is greater than our required sum, we move to the next element as the starting point. Because all the numbers are non-negative, so our sum can never decrease whenever we add a new number. Now we move to 4. From 4 we check that now we count the 4 as the starting point, start creating subarrays with it. So 4 and 20, 24 not equal, 27, then adding 10 equals to 37, that is greater than 33. So still the 4 is not the candidate for the starting point. We move to the next element, that is 20. 20 and 3 equals to 23, and then we add 10, this equals to 33, which is equal to the required sum. So we just return the indexes of 20 and 10, that is the starting and ending of the subarray. So this is the naive solution to the problem. So now let's look at the implementation. So what we have done, first we are taking three variables, that is current sum, I and j. I and j refers to the starting and ending point of our subarray. The current sum will actually store the sum while we will be traversing through the array. This sum we will compare with the original sum that we actually want, and we will check if both current sum and this sum are equal, then we will return our I and j values. Correct. After that, we have started another loop. This loop picks up the starting point. So as discussed, first we need to pick up a starting point. After picking up a starting point, we put that starting point value inside our current sum. Because if you notice that in all these array, the starting element is also included. After putting that value, we start our second loop that goes from I plus 1, that is after the starting point, till the end of the loop. And inside this, what we do, we first check if our current sum equals to sum. So what does this check means? That suppose if our sum would have been 1, then we would not require the addition of 4. So this will only be a required value. So before adding 4 or any other value, we check that whether our current sum is already equals to sum. If that is the case, we just return I and j minus 1. Not j, just j minus 1, because we haven't added the arrj value to our current sum. Fine. After this, if this is not the case, what we do, we also check if our current sum is greater than sum or not. So this is the case that when we are, this is this case, that is when our sum overshoots the 33 value or the sum value. In that case, we just need to come out of that inner loop and go and pick the next starting point. So that is why we have put the break statement in this case. If this is also not the case, what we do, we add the jth element, that is we add the next element and then check whether that is equal or not. And this is how the whole loop is going. So if we do not find any subarray after traversing the whole ith loop, that means there is no subarray possible. So at the end, we just print a no subarray possible. So we have seen the naive solution implementation. Now let's see how we can implement this using our sliding window. So this is our array. This is the required sum, that is 33, and here we will write the window sum that we will be traversing. So initially, let's just say that this is our window. So our I as well as j both will be pointing to this one. So our window sum is 1. After that, what we will do, we will shift j one step right, and so our new window will now become this much, and the sum will be 5 now. 5 is not equal to 33 and 5 is less than 33. So what we need to do, we need to add another element inside our window. So we will move our j one step towards the right and add 20 to it. So this becomes our new sub array. So our sum becomes 25, that is 20 plus 4 plus 1. Now 25 is also not equal to 33 and 25 is less than 33, so we need to move our j one step right, that is increase our window size. So j comes here and our sum becomes 28, that is adding 3 to our previous sum. 28, correct. 28 is not equal to 33 and it is less than 33, so we need to add another element, that is 10, and shift our j rightwards. Now our sum becomes 38. 38 is now greater than 33. That means if we will now move our j one step right, then the sum will keep on increasing and will never reach 33. So we have to decrease the sum. So we need to decrease the window size. But we will now decrease the window size from the left, because from the right we have added each element and checked whether they are actually causing 33 or not. So what we will do, we will move our I one step here, that is remove the element 1 from it. So 38 minus 1 equals to 37. So our new window will now be from starting from 4 and going till 10. This equals to 37. 37 is not equal to 33 and 37 is still greater than 33. So what we need to do, we again need to move our I one step right and start from here. So our now the window becomes starting from 20 going till 10, and we need to subtract this 4 also. So 37 minus 4 equals to 33, and this is our required answer, that we want 33. So our subarray becomes starting from 20, then 3 and then 10, and this is our subarray that we want, and our I and j respectively stores the starting and ending of our required subarray. So this is the optimized solution that we can actually do using the sliding window technique, and this will actually take only O of n time, because we are just traversing once and just moving our I and j pointers right or left. So now let's look at the sliding window implementation. So this is the array, this is n, this is sum. So let's create a variable that is window sum, and window sum will store the first element of the array, because we first consider only the first element as the first window, right? And then we create two variables, that is start and end, and this will store the starting and ending of the window. So let's start equal to 0. This is the index of the window. So we start our first window from the 0th index, and we will traverse our end from first till end. So basically we will move our window rightwards using the end variable. So we start from end and we just reverse n plus plus. Now first thing we need to check that our current sum, that is the window sum, if this is greater than sum or not. So by chance if our first value would have been 34 or anything, so we need to first check that whether it is greater than sum or not, right? If this is the case, right, and we need to just subtract the ith variable, that is move our ith variable or the start variable forward. So what we will do is we will just do window sum equals to window sum minus ARR start and start plus plus. So we are moving our window rightwards from the start when our window sum is greater than sum. And what we can do is we can just do it in a while loop, because there is a possibility that even after removing the first element from the left, we still have the window sum greater than sum. So we need to do it till the window sum is less than sum, so that we can move our end towards the right, correct? And what we have to do again is that we need to check whether our start is actually less than I minus 1 or not, or we can say start is less than n minus 1 or not. This is because while just subtracting the values, we have to take care that our start should not overshoot end. That is, the window should not just be in the reverse manner. Correct. So this is our first check. Now after this, what we will do, we will just check that, okay, after subtracting some values from the left side, we just need to check that whether our window sum is equal to sum or not. That is, we have found 33 or not. If this is the case, we just need to see out start, and this is our starting index, and we need to see out end minus 1, not end, because we haven't added the end value till yet. Okay, so this will be our case if window sum equals to sum. In any other case, we just have to move our window rightwards. So what we need to do, window sum equals to window sum plus ARR end, and our end will be incremented automatically using our loop. So with this statement, we will be able to get our required answer. So if I run this one, our answer should be 2 to 4. Right, we have got 2 to 4. So 2 is the starting index, that is 20, and 4 is the ending index, that is 10. So from 20 till 10 we get the subarray, and this is the sliding window implementation of the above question. So that's it with this video. Thanks for watching. Stay tuned to add more festoons into your knowledge garland, and till then please keep subscribing. Thank you.